To welcome our next speaker, the Sir Enrique López Mañas. He'll be talking about the event-driven programming for Android. He has arrived here as a Google developer expert from Munich. And please, on stage. Yeah, I will take it.
So thanks everybody for coming. Thanks also to the GDG Istanbul for the organization and for the invitation. And as it has been said, my name is Enrique. We will be talking about event-driven programming, and as you can read, not reactive. That's because many people confuse event-driven programming with reactive. That's the third time I talk about event-driven, and I remember the first time I got asked like for half an hour about and why reactive is doing this and why reactive is doing that. So it's better to clarify it from the beginning. Just very shortly about me, I'm an IT consultant, I'm freelancer. I'm part of the Google Developer Expert Program for Android. And you can see here my Twitter ID. I will post there the slides and the code I will be using. I will be doing a demo at the end. Just first a question. I see many people here. How many of you is familiar with event-driven programming for Android? Okay, that's not that many. Less than 10. How many people knows reactive? Okay. Well, that's good because it's not many people, so I hope you can benefit of the talk and learn something at the end. When we talk about event-driven and reactive, we talk about a programming paradigm with an implementation for Android. They are similar, and some of them always share one thing. They share that when there is a modification, it's about communicating to another components in an application. What I'm going to talk today is event-driven. If you've been designing hardware, it's this paradigm where we have a central bus and we post a lot of information. This information is distributed to another components of the hardware. It's just that this paradigm is applied in software. We also have the observer pattern, which is partially the one reactive Java is applying. So in observer, when we implement an observer pattern, we have an item that is observing another one. So every time there is a change or a variation, the observer gets notified, and then we can apply an action. For example, we can think in terms of Android. We have edit text, and every time we are modifying its content, that means we are typing, we can apply an action like activating a button. For example, if we want to log in, we will only activate the button if the username and the password have been already entered and validated. We have another patterns like pub sub, pub subscriber. It's similar to the observer, but it contains topics of aggregation. So when we subscribe to a topic. If you have been programming with MQTT, this system for real-time notification, you normally subscribe to a server, to a particular topic, or to a particular theme, and then you get all the notifications that are happening, so you can get whatever socket is being sent. And also we can think of data flow programming. That was a paradigm or a pattern coming from C++, very similar to event-driven, but originally dealing with a lot of things of memory and everything. Reactive. Reactive is probably more famous than event bus. When we look in Google, reactive against event bus, or we can try, and there is this tool in Google, the Google trending, where we can see the number of results we get for a topic. Reactive is much more. It's a library originally designed for Java. There is a library for Android called RX Android, which introduces a few optimizations for the Android platform. When we think about reactive, we think that everything is a flow. Nothing is statically connected anymore. We can connect any element with any other element. Reactive is a little bit more declarative and less imperative. What's declarative? Anybody knows? What is that? So declarative is when we are programming, we don't program, or we don't say to the compiler, how do we want to do things? We say what we want to do, and then the compiler take care of the details. So in this sense, reactive is a little bit more flexible than event bus. And reactive is a local solution. It's a solution that we can use to connect very different items in the case of Android, inside an Android application. And event-driven is a little bit more global. Event-driven is an architectural solution. Now this is a hot topic in Android, how to organize an application, how to apply clean architectures, MVP patterns, etc. Event-driven came a little bit to solve this problem, how it's possible to communicate and to decouple an Android application without falling in a lot of complexity. In event-driven, we will have actions or events. So every time something is happening in the application, an event will be triggered into a central system. This central system will be connected with another components. We will call them subscribers. And when an event is happening, the subscribers will take an action if they are subscribed to this event. Event-driven good is very good for decoupling and communicating items. Decoupling means that the items are no longer connected and no longer know the existence of each other. That makes the our applications, our system very robust. So we get rid of a lot of those ugly null pointer exceptions. And it's also very useful to communicate elements. Android doesn't give us a very clear pattern to follow on how to communicate, for example, between fragments and activities. And with event bus, we can communicate pretty much everything between themselves. This is a typical picture of how an Android application looks like. If you've been working with Android, sometimes you have a fragment where it's holding the view, the activity is holding the fragment. You might have different activities. It's a little bit ugly how we communicate between the fragments, how we replace them. Then we have a service that is lost and is communicating with a thread, and at the end, everything is a mess. We have a static value, we have a static class, we have a lot of singletons that are holding the information, so that makes a lot of memory leaks. Applications are not responsive. A big problem is that the code gets very complex, so it's easy to make a simple application, but when the application begins to grow, that's when the real software engineering starts, when we have to make everything work and extendable and ensure that the software will be working after 1 year and we don't have to throw it and start again. This is how it looks with event-driven. Just I will show an example later, but that's the conceptual picture. We will have this central event bus. That's where all the messages are being sent. And we can connect pretty much everything to the event bus. Here we see how the fragments are connected. The fragments can put messages into the event bus, the activities, the threads, and everything can talk with each other without knowing of the existence. So in this, for example, in this slide, we see that the fragments, they don't know that there is an activity, they don't know that there is a thread, and they don't need to know, which keeps the logic very, very simple. The fragment just needs to start the view, the thread just needs, let's say, to perform this background operation, downloading a file or making an HTTP connection, and they don't really care if a fragment is listening or not. They just get the information and post it back to the event bus. There are different alternatives. I can recall these three. Greenbus is from a company in Munich, in Germany. It's probably the oldest alternative and the most stable one. It has a lot of contributions. On the other hand, it's not that more maintained anymore, which it's maybe not necessary if it's working, right? But yeah, there are some bugs that are not being solved. Otto is from Square. Do you know Square? How many people know Square here? Okay, for those who don't, it's the company that really programs Android. So all the libraries in Android are done by Otto, by Square, by a guy called Jake Wharton. He's programming every day. If you see the Git, in GitHub, there is like this resume of summary of commits, right? He has like the entire year, everything green. So it's interesting. And yeah, Tinybus. Tinybus is a very small alternative. It's very lightweight. I think it's less than 100 kilobytes. So for a small prototyping, is definitely a good alternative. I had tried for prototyping and it works. It does work. It's difficult when you want to expand and add some more functionality. Here there is some benchmarking. So EventBus defeats Otto in terms of performance. You can see here in this slide how much it takes to post 1,000 events in different emulators, register the subscribers into the bus. So that pretty much means telling the bus like, hey, this component will be listening for new messages. And then also registering the subscribers called starting. That means when the emulator or the phone is just starting, we create this a register for the subscribers. We put all of them, and it's well, it's about the same in Android 4.0, but in all the other scenarios, EventBus pretty much defeats Otto. Some more things. EventBus handle the methods using name conventions. So we need to declare a method called onEvent and read an event. That's something bad because we need to rely on reflection. And if you program for Android, you know that reflection is a no-go thing in the Android world. Otto uses annotations, which are, I like them in terms of code simplicity and code cleanliness, but they are slower when you need to understand them because they are done on compile time. And there are a few more things that EventBus are supporting that Otto is not doing. So in EventBus, EventBus and Otto, we can inherit events. EventBus, we can inherit subscribers, so we can create a full hierarchy of all the subscribers that are going to be listening to the events. There are stick events. That's kind of a catching mechanisms. So when we need to hold an event in the event bus to access it continuously, I can think, for example, if we have logged in with a user, we want to keep this user all the time available in the event bus so we can access to the, let's say, password or hash code or username, etc. And yeah, a few more things. In EventBus, we can post events, deliver them in a posting thread or in the main thread, which it's there was the talk before was about optimization. So I understand this thing of posting in the main thread, but sometimes might be useful. And yeah, there is also asynchronous event delivery, which can be really good in the case of EventBus. If you have been programming with Android, you might think, okay, but this is similar to a broadcast receiver, right? Do you know broadcast receivers? So you know, it's this mechanism we use when there is an action being performed in the system, like the phone is starting, or there is a incoming call, or we have an incoming message. Then the broadcast receiver appears and then notifies to the application that something is happening. It's not exactly the same, and EventBus has some advantages. Broadcast receiver need to use with this intent system. So that means we need to set up the intent, we need to implement the broadcast. When the intent is being sent, then we need to extract all the information. So that's quite a little bit of an overhead. And EventBus is using standard Java classes. That means we can benefit of many Java libraries. We can use whatever object is being created with the intents. We need to rely a little bit more on this system to add primitives and extras, and we need to implement our parcelable or serializable, so it's a little bit more limited. And EventBus, as I said, is something more global that helps to architecture our application. Main components of an event-driven system. We have an event bus. Think of that as a cable or a conductor where we put all the messages. We will have events. They are also known as messages in similar systems. We will have the subscribers. Those are the elements that are trying to listen to an event being posted. And we will also have publishers, which are the items sending elements to the event bus. Also, it's worth it to say that a publisher can be a subscriber. There can be an element, depending on the architectural decisions we take, that we'll be reading and we'll be also posting. And this also makes sense sometimes. If I receive a new event, maybe if I, let's say, I logged out my user, maybe I want to clean the file system of all the files the user has been downloaded, for example. Conceptually looks a little bit like this. We will use a method called post to post into the event bus. And then this event bus will send to the subscribers that are subscribed to this event. That means if we take out a subscriber, or if there is no subscriber listening to the event, nothing happens. What means that's the real meaning of the coupling. The application will not crash if there is no subscriber. We will just get the event lost, nothing happens. Still there are mechanisms to recover, but we ensure that there is, if we try to update, for example, a screen, and the screen is at this moment not present, nothing really happens. How do we start with the code? This is just some basic snippet. We need to, I'm using GreenDAO in this demo, GreenBus. And we need to register first the subscribers. And the method on create or on start, there is some discussion. Some people say, why not on start, or why not on create, on resume? I normally do it on resume. That means when the activity or when the component is coming, then I register the component for event bus, and I unregister it on destroy. Why is that? Because maybe it can happen in a component that I get a call, right? So then my activity or my fragment, they go into the background, but I want them to keep listening on my event bus. If something is happening, I want them to update my data model or take any decision. If I unregister my subscriber on destroy, then I ensure that it will be listening whatever happens with the application as long as the component is living. That's another example on how I can post events. So in this case, if you have been working with fragments, that's always very ugly, because you need to get this fragment manager, you need to start a transaction, you need to replace, you need to remove, sometimes you need to keep a track of all the fragments. So here is an example on how to attach fragments. We will have this on event on our main activity. Every time an event call, attach fragment event is being sent, we get, if you see here, there is an event.getFragment. That's because we can send information on the events. The fragment will be read, and it will be commit to the system and replace into the screen. That's an example of how I can read an event and then post an again. So in this case, we have a subscriber that is also a publisher. The method on event is looking for or waiting for the second fragment event. And when this event is coming, you can see that I'm posting a new event. That means when the second fragment event appears, then post the second fragment into the screen. I have mentioned before the stick events. Stick events is when we want to catch, it's a solution that sometimes can get a little bit complex, right? If we want to implement our own cache and last recently used mechanism, etc. Well, with event-driven, that's quite simple. We just use an stick event. And a stick event means that the event is not being consumed when it's being sent. With a normal event, those events disappear as long as they are consumed. In this case, you see that I'm sending this second fragment event. So when it's consumed, the event will still be there. When it's consumed, the event will disappear. We cannot access it anymore. If we use an stick event, the event will be there all the time, which can be very useful for global information or catching information that need to be caught on the application. So now, that's so far the theory about event bus. That's something very general things. Now you know what is a subscriber, a publisher, but we need to support this in Android. And for that, we need an architecture. How many of you implement MVP architectures? Okay, not many people. I'm surprised. Yeah, so the architecture is a very important topic when we are developing. Software engineering is definitely about handling complexity. That's the main topic. When we are doing a hello world, when we download a tutorial, when we are starting with a technology, everything is going to work. We buy this book with how to learn Scala or how to learn Dart. We make the first applications. It's working. That's really cool. Problems came when we need to scale. When we have a team with 4 people that need to be working at the same time and they need to be working maybe on the same model, how can we separate this? How can we make that everything works without anybody being accommodated, without destroying the works for each other because we are working in same files, etc. That's one of the reasons why we should apply clean architecture. So MVP stands for Model View Presenter. In this case, the model is the definition of our objects. We will have an object modeled, an abstract object that is represented in our classes. We will have the view. The views are partially supported in Android, right? We have fragments. We have layouts. The layout can be a view, right? It's a representation of something that appears on the screen. But that's the only thing we have in Android. We don't have really models or presenter, not natively. We can organize it, but Android doesn't give us clear guidelines. And the presenter is the layer that connects the model and the view. So the presenter knows how things must be sent to the view. So takes the model, deals with them, and presents them to the view. An example that I always like to say when I want to enforce or I want to promote the use of clean architectures is, let's think you are reading data from a database. If you don't have any kind of separation, you will have all the code to read the database, prepare the view, and paint it on the screen. And then you want to change into a web service. The database is not longer local. We need to read it on real time. If we have this kind of architecture, it's something super easy to separate, because the view will be the same, the model will be the same. We just need to update our presenter. Our presenter just needs to fetch the data from a web service, deal with it, and present it to the view. So it makes the code much better to extend and much more optimal and much more performant. Yeah, I've said that Android is not a pure MVP. There are some solutions, but we need to implement by ourselves. If we need a presenter, if we need a model, the views are still there, but it's not truly complete. So that's, I'm going to show you now some live code very shortly on how an event-driven programming look like. We will have a registry with all the subscribers. If you've been working with hardware, a registry is this big box where you store all the variables. So we will store all our subscribers there to keep a track on how they're working. The event bus knows about this registry, and then it will get all the information contained there. The code is here. I will post it anyway in Twitter, so you can download it later. There is also some little information about architecture and implementation. So if we can hear to the main activity, can you see it good from the last rows? Good? Okay. Yeah, so this is an activity. This proposal of architecture only uses one activity. We can see that when we are starting on create, we register our main activity. When it's destroyed, we unregister it. I'm using here, by the way, this is the default one from Event Bus. Here I have created my own component. I think it's when you are programming, you normally end up with your own component, like my base reporting activity, for example. Yeah, here when it register, you register sticky components, etc. Yeah, and this activity has this method on event. Every time there is an attached fragment event, this method will be called, and it will start the transaction. I'm going to compile just to show how the application looks. It's something super. So you know there is always this demo effect when you're trying to show something. I thought that was a feature of Android Studio. Like they have probably a section like a demo effect. Like if you're making a demo, don't let things work. But now it's also on Android Studio 2.0, so it's maybe something different. It's not a feature. Okay, while it's loading, I will show you a little bit of the other things. So basically, this application will have two screens. In the first one, we introduce some data. We can like username, login, and password, and we click on next, and then we move to the next fragment. Yeah, that was very fast. It's even here, I think. Yeah. Okay, so basically we have a username, password. We log in, and then the login is correct. Sorry for the design. I'm a very bad designer. Yeah, if we can here to the login fragment. So you can see that the code is really, there are a few more classes than we should have for a hello world, but the code is really very, very clean, and it makes everything very easy to extend. This fragment has a presenter. Is this presenter for here? As we said, the presenter takes the action. the fragment, this is how a fragment should look like, even if the fragment is very complex. We will just need to extend our classes, and there should be like absolutely no logic here. The presenter, when we click on the button login, the presenter performs a login, taking the information, the string of the edit text username and edit text password, and post the event. Do login event with this information. Send into the do login event username and password. By the way, does anybody knows this annotation from here? Butter knife, that's right. So if you haven't used it, it's something amazing. Normally in Android, you need to make this button dot set on click listener, new on click listener, override a method. It's super ugly. It would be like, I don't know, 15 lines or 20 lines to make anything. Here with this annotation, you just make annotation, ID of the element, function, everything working. You have it for most of the interactions, so it's something really, really cool and really functional. Again, to the presenter, we post this event, do login the event. This is read on the login subscriber. As we said, the subscribers are the one reading elements and dealing with elements. Here we will get the do login event. Here I'm posting the so-second fragment, but here there will be more logic. In this class, we will probably want to make an internet connection, get the data, verify that the data has been right. If it's right, then we post the so-second fragment. If not, we will post the so error while doing login, etc. And then, in so-second fragment, we will came here to the main activity and so the fragment. I'm going to make some debugging just so you see how it's working. Debugging takes a few seconds more, but should not be much more. Okay, so here I'm posting the same. I click on login, and the debugging is not working. Okay. Well, I think I need to restart, so I'm not going to do that. But yeah, basically, when we are posting, all the on events are reading all the information and dealing with it. Now, yeah, as I said, this is a very basic example. The subscriber I wanted to show, the register, sorry. Yeah, and the registry here, that's a very, that's my custom registry, right? That's where I will register the default subscribers and where I will unregister them when the application is exiting. I do it from the application. I have my custom application here, ED application, where I start event processing. I create my bus registry, and I register all the subscribers. Here you can see that I have the login subscriber and the second fragment subscriber. Those are the elements that are reading all the information and dealing with that. Second fragment subscriber, when the second fragment is being sent, post event, attach fragment event, etc. But as you can see, the code is very clear. If I want to create a new feature, here I will come and I will, can you see it? Yeah. I will, if I want to, for example, make a new feature log a modify profile, I will create here a new folder, modify profile fragment, presenter, and subscriber. I know what each thing I have to put in its folder, and it makes the code very extensible. That's one of the problems when we are developing code. We take technical debt. Sometimes we have to make refactoring. We need to throw our code. What should take 1 week is taking 3 weeks. With this system, is one of the advantages that the code gets really handleable. Yeah. Just so you can see the difference with the reactive Java, I think this is a very good example. This example, as I said, reactive Java can be more local. With reactive Java, we can, for example, connect a text element, edit text, and when the fields are being changed and are being validated, then we will update our button to login. So here we have the text email is being observed. Then we will make sure that the text is changed with the text change map, validate inputs. It's a call to a function, so when it's validated, start with false, make sure that from the beginning the button is disabled. And then it's subscribed to the view actions.set enable of the button submit. So when things are changed, we just, normally you need a lot of logic to handle it, right? Like if this then set button, set enable true, set enable false, so you can see also that you get rid of a lot of boilerplate code. And the important thing, you can combine both. So event bus can be done for the architectural decision, and reactive Java can be done for these local things of handling logic between components. Benefits of event bus is lose a lot of decoupling. So you will have each class doing what it has to do, which enforces a lot of testability. When you want to test, if you have everything in a class, it's a hell, because you need to start mocking elements, you need to rewrite components, you need to fake a lot of things. If everything is in a single class, that's super easy to test. Intercommunication, we can communicate everything in using event bus. So we forget about using interfaces between fragments, etc. And for me, the most important one, and where I have very good results with event bus, is the scalability. When we are developing something that is complex, we make sure that it's scalable, and we make sure that we can keep on working with this system after 1 year, and we will not be throwing our code to the garbage. Some problems, because nothing is perfect. At the end, when we are developing software, we need to find a compromise between good and bad things. There are nested events that can be a problem. When we have an event that is depending on 2 events, that needs to be done manually. There is no mechanism provided from event bus. Can be problematic. We are treating the producers also like synchronous getters, right? So we are waiting until a producer is sending something, and then I get the information. This can be conceptually a disadvantage. Debugging can be problematic. It's slower to read elements from the event bus. There is a classes explosion, and I think I can probably show you a real-world project. Especially with the events, we need, at the end we will finish up with a lot of events, like almost for every action we are taking. So you can see this is a project I was working with. So you can see there are a few events. And here it becomes very important to have a good naming convention. If we are having so many events, if we are having like maybe 100 events or 200 events, we need to name them very well. Like, do show something, do perform action, do remove, do delete. Like if we are having a CRUD operation, like create, remove, delete, modify, we can use those patterns to name the event, so we know exactly where to go and which event to read. But at the end of the event, you see they are very small. They don't have like some extra information or anything. By the way, another question: does anybody knows this annotation from here? Lombok, that's right. Not many people knows Lombok. So you see that here there is no constructor, there is no getter, and there is no setter. That's because I have this annotation. If you use Lombok and you use this annotation, you automatically create the getter, setter, constructor. You can even set up Lombok to make the implement serializable and has maps and everything. So it's a super cool library that I totally recommend you. Yeah, and yeah, sending data in events. Sending data in events is a little bit the equivalent of having static data in a normal application, which is not always the best solution, because we can face some memory leaks when the data is not properly handled. Here it is a little bit, if it's well done, it's not that complicated as long as we are registering and unregistering our components, because then we get rid of the data. But we need to be careful with that, because if not, we can finish with a lot of memory, objects in memory that we are not using. So that was everything. Before we go to the questions, I would like to get your feedback about the talk. If you go to this address, I will post it also later in Twitter. I will send my book randomly to one of the persons giving feedback. So yeah, just write very honest comments there. I will love to see them. And that has been everything. Thanks a lot for being a wonderful public. And if you have any question or anything you want to learn about.
I want to ask you something about. Actually, I'm using this event bus kind of libraries with my some kind of problems. For example, if I want to inform the activity when the charge status is changed, this kind of things. But I checked your code, and you are always using event-driven development methodologies with all of your events. Is it good? I don't know. Should I? When should I use this kind of usage, or when should I? When should I use it? Doesn't use this methodology, or can I feel free for this on all events?
As a rule of go, I use event bus when it's about intercommunicating components. If it's something local, let's say modifying the example I saw with the did text button, I use reactive Java. I don't care about event bus. But if I need to talk with one fragment with each other, if I need to talk with a service with another fragment.
You're using the event bus for button click.
Yeah, that was an example to show, but in this case, I would show the reactive to connect it with the event. So when the button is being pressed, then I will call reactive, because it's local and I keep it local in the presenter. But I will keep when the button has been clicked, if I'm performing, for example, a network operation, I will do it with event bus. So event bus will send the event to event bus, and then there will be another subscriber that makes the network operation, takes the result, and send it back to the event bus.
Synchronization in events bus?
No.
So
there is it has to be done manually, it has to be done thread safe. So that's is one of the inconvenience.
For event bus, how can we avoid one bus architecture disadvantage, like difficult to identify the problem if system crash?
Can you repeat the question, please?
How can we avoid one bus architecture disadvantage? Like if system crash, we can't identify which part what's the problem.
So the event bus at the end is a class. What I do is I take the event bus class, like event bus the one of greenDAO.getInstance. I create my own my own bus, and then I have a method. When there is a crash, I write all the information of all the events in a file, in debug mode, not in production mode. So you can customize your event bus, and then create a method to write on a file continuously. Every time there is a new event being posted, so if there is a crash, you can recover the information there exactly from its event with all the information that is being contained at the moment.
About this, right?
Yeah, there is no mechanism from event bus.
Can you suggest a more detailed documentation, or where can I find that?
About event bus?
Yes.
Well, I will post it later. I don't know if today, because there is no internet, but I will post it to Twitter. I wrote actually 3 big articles in medium.com about event bus, so describing this architecture more in detail and explaining it. So if you check it, actually you can even check it now. I think if you go to the last week, I already have the articles posted.
Of bottleneck when it's compared with the approach. Can you hear me?
Yeah.
When we compare this approach to broadcast and intent, is the only advantage of this approach is writing less code?
No, it's not the only approach. So of course, writing less code is an approach, but it's more in general it's more flexible. Broadcasts they still can be customized, right? We can write our own broadcasts, but they are depending on the Android agenda. So Android schedules the broadcast. It's not as with the event bus. We know that we post them, we know that we read them, we specify which components are reading them. The broadcast to the entire system. We need to have the component in the application that is reading, etc. So in general, it's I would say broadcast. It's good for the default. The default broadcast receivers are really good because you can get all this information from whatever is happening in the Android system. But for custom things, the main reason is that it's a lot of work or more work, and it's definitely less flexible than using the event bus approach.
What can you say about battery consumption?
It's not a big problem. I track it. I actually, in my applications, I have a debug mechanism on the event bus. I track the battery consumption, and it's more since it's more code, but it's not really a problem.
I want to start developing apps for Android. Where should I start with? Do you have any suggestions for me?
The website of Android developers. It's probably a good. Yeah. Well, I think coming to those events is cool to get like big picture of everything. Because if you start by yourself and you don't see any code, you get lost. But I would probably take what I think I started with was or a good amount of things I started with was when you download the Android SDK, you have all these samples. So just go through the samples, set the code, make small and stupid modifications. You know, like if you're going to read all the messages, then try to read them and add new field or something like that, and make your. I will try to publish one application that does something very small, and from there iterate, and it's a natural process.
Can you say some examples of applications in Google Play based on event driving? And is the Play itself is the event driving?
No, Google Play is not event, but I can tell you the ones I was doing at my previous company. You know, Drive Now. It's like Car2Go, but for Germany. My driver is like Uber, but for Germany. Do you know Sixt, the car rental company? Is everything done with event bus? I have a couple of personal ones with event bus. In Germany, I'm working with a couple of clients, but it's only for Germany, so I don't think you will know them. I think, which company was that? Well, Square is using Autobus, not event bus, but is using also the applications for Square and are using events. Yeah.
Button knife method. And can you shortly summarize, please?
If I can, so.
Button knife method. What was the function?
What is the function? It's, well, I think I should. Yeah, so, well, this project is a little bit huge, but if I can do a fragment. So basically, you get, now it's, I will need to build, and so you don't see it red, but basically you have you can make this on click for all the events, or you know, every time you're clicking, every time the text is changing, you don't need to implement the override, you don't need to do all this extra thing, which is like just that, like 10 lines. You just can make it like this. And there is something very cool. You can inject the view like this. So instead of making, put my layout that get element by ID into a text view, you just make an inject view into the recycler view or the text view, and it's automatically done. You just need to make on create, yeah, I don't remember exactly what in the on create or on the activity you need to make butterknife.start or something like that to start the annotation reader, and then you can get rid of all the listeners pretty much. No, that's a good question. You can have several of them. Modularity, but I think it increases because if you have one, everything is centralized. If you have two, you have subscribers, producers connected to each one of them. If you have three, you have two groups of subscribers, three groups of subscribers, three groups of subscribers, of publishers, three event buses. So debugging is hell. I can understand it in a very small context. For example, you want to have an event bus for debugging. Anytime something happens, you post it to a particular event bus, and then you read this information. But as a general thing, to use several of them, I think is a bad idea.
Bigger application, most of the bigger application developed with methodology, or is it the mutation, or what's the alternative of this methodology for bigger applications?
Well, this is an architectural solution. Some people don't use event bus, and they use everything with a combination of asyntax and reactive and everything. But in my experience, I've used some clean architecture. I've used reactive, like in architectural terms. Event bus is the thing that I know if I do it right from the beginning, after 6 months I will be working with more or less the same overload. You know, code always increases and you have technical debt, but I have really good results with event bus. And about? In the market in general, I think it's not a well-known alternative actually, and I'm surprised because if it's well used, it's quite well. If it's not well used, no, like everything. But it's not that when you go to any conference or you talk with you see the Android Weekly newsletter, for example, reactive is like almost everything. And event bus, I think I haven't seen any big articles on the net, which is surprising for me.
What about memory optimization? Would you recommend it event-driven for memory?
Well, it's not a big change regarding the old paradigm, because at the end, you don't consume any extra memory. The variables you have, you still have them in the events, which is like the thing of having it statically. But I think it's more safe in the sense that if you make sure that all the events are being unsubscribed and all the registers and publishers, there are no memory leaks. Whereas in another application, if you have a static class and the activity is still alive, you know, it might be on the background, but it might be still alive. The memory is still occupied. So that can be a problem. And here you can ensure because everything is on the event bus and on the registers, if you unregister it, the memory goes out. So it's a better system to control memory leaks. Yeah. Everybody's leaving. I think if you have any question, you can come here and... Okay.
For great presentation. Publishers' work is expensive, I/O intensive or CPU intensive. Is it convenient to check for any subscribers, if there is any subscribers?
Yeah.
Or is there any other design pattern other than image driving for this? For example, a company, for example, screen recording, I/O intensive. If there isn't any subscribers, I don't want to consume CPU power.
Yeah.
Is there any other design pattern?
Good.
Is there a special method in event driving for this?
Not really. To check this consumption, what I use is, the last presenter was mentioning a few tools. You can use this tag to tag into the when there is an intense memory consumption, you can tag the memory and write it in files. That's what you can do. What I do for debugging, and I think it's a good idea with event bus, is every time you have these flavors in Gradle, right? When you compile in debug and you compile in release. When I'm compiling in something that is not released, so it's typically a debug version, I'm painting continuously all the information in files with all the status, with memory that has been reserved, memory that is still free, times of the number of times that the memory is being allocated, etc. And then I keep it as a log file for the event bus. But there is no really big pattern to.
Any subscribers, if anybody is listening to me, I have used.
Yeah, of course, because if not, you can end up in a dead situation that nothing is being read. You know that events are being sent and are not being consumed, definitely. But you can do that with the event bus because the event bus is everything centralized. You can also connect with when an event is being put, you can see, okay, this publisher published the event, and then this reader consume it. And if it's not consumed, you can also make a signal like this is not being consumed now. So when you're working, I have this big file. I check it, I don't know, once every week, and then I see if something is not being consumed because, you know, if you're working several people, it can be that a person removes one of the publishers and then nothing is happening because the application is not crashing and you don't realize. So I do that through logging into the main event.
So can you configure the event bus, for example, discrepancies or max number of active events or template for events, etc.?
You have that natively with event bus. You can have like a time to die for the events and. Yeah.
Okay, so I can say, okay, I have lots of events, but there's a memory problem, so I want to discard some of the events from the event bus, even if it is not consumed by the subscribers. So event bus can manage all these kind of events.
Natively, event bus from Green bus, yeah. Auto, I don't think so. Auto is a little bit more primitive, but event bus has a lot of stuff like post delay, positive condition, and more questions, yeah.
With performance issues written in classical way, you prefer commenting in event-driven way.
I didn't get the question, sorry.
I have a net written in classical way, not event driver. You prefer converting it to event driver?
It depends a lot of conditions. Do you have a big team? Is your application gonna be finished as an application can be? You have like a long roadmap. Are you having any technical depth? So it's a complex answer. In general, unless you don't have any resource, I think it's a good idea to use one of those strategies. Even thinking about when you talk about the manager, sometimes you need to convince them that I need to refactor this, and they say, no, it's very expensive. You need to convince them, no, expensive will be if we don't do any refactoring. And you need to say expensive, because if you say time, they say, time. If you say expensive, they think about money, so it's more efficient. And at the end, it's definitely much better, because when you're getting technical debt, things are more difficult to develop. Sometimes you're even stuck because you cannot do any refactoring, applications are not responsive, and sometimes if you do it in an early advanced stage of the application, it can be like a super nice solution to avoid future problems. Yeah.
How publisher sends Java objects to the subscribers? Is it using serializing methods or some kind of caching?
Well, you should use an Android parser label, not serialize.
Is it or is it creating static objects? Which way is
for cutscene?
No. I mean, how publisher sends Java objects to the subscribers?
You just send them. You just post the entire object. That's the good thing. You don't need to care about anything. You just well, the object needs to implement. It needs to implement serializable at least. Parser label is better, but you just post the entire post. Say, I don't know if I have. I probably have. I don't have an example here, but basically when you post an event, inside the event you just put the information you want. It can be primitives, it can be objects, and that's a good thing. When we were talking about the broadcast receivers, you need to make intents with adding the extras and the bundle. Here you just post the objects as they are, which is more natural. If I want to log in, for example, I will send a user, or I will send a username and a password. I don't care about serializing anything. More questions? Okay, then there was a lot of questions. Anybody can come here and grab books and cardboards. And thank you very much for being here.